Mm. Last time we did binary search, iterative implementation. Now we will do binary search variation. There are very certain variations and famous variations in a binary search. So there is one famous question that we will solve. Okay, so the question is finding the first occurrence and last occurrence in a sorted array using binary search. Okay, so what this question mean is, if suppose you have like some integer type of array, let's assume, and it has some elements, 1, 2, 3, 5, 6, 6, 6, 6, 6, and 7 and 8. Okay, so here we can see 6 is like repeating itself. Okay, so if I have to like search in for a 6, so whatever the number comes first, our program will return that particular index of that number, right? If my middle is this, and if I'm searching for 6, so it will be like return this index. But first occurrence means the first time in a sorted array, the element is occurring. So to find this, we will use a variation of binary search where we can find the first occurrence. Then we will do another variation, uh, last occurrence. Okay, so let's do it. Okay, so do this first. We need same thing. Uh, what is our like basic binary search program look like? It always has start, which will be like 0. Then there will be one head which will be array dot length -1. Right, and after that what we do mm, while start is less than equal to 1, right, and we will always find the middle, right. So to work to like find a middle, we use one trick, right, which is more suitable. It's not mandatory, but it is a good program practice. That's why we use it to maintain the overflow, right? This is the basic binary search, right? So find the middle and all. Mm, if suppose we are finding x, okay. So our int x equals to 6. We need to find sorted array 6. So if x equals to array dot mid means middle, right, on a first iteration. So we will basically do what, print our mid, the index, right. So if I do this, it complete this, else if x is less than array of mid, so do what, we have to do um, end equals to mid -1. So it will basically do what, it will, if end will become mid -1, that's mean the fifth position from the left side. Okay, else if this is false, then automatically the second condition will start. So we will do mid +1. Okay, so it will start will be mid +1. So it will give us the index starting from here to here. Okay, basically this line means this for the second iteration. If x is like not at this position. Okay. Okay. So if we will going to run this program, what will be the outcome? As you can see, it is giving me it when in infinite loop. Okay. Why? Because I haven't like used break. If we make a function separately, so we have to return. Otherwise, we have to break. Okay. So since I'm breaking the loop, if you see, let me if you can see the index is giving me a 4, right? And 1, 2, 3, 4. So our program is actually giving a wrong output, right? So how can we fix this? So we will create one extra variable called result, or we can call it answer also. Answer equals to, will save initialize it with -1. The time, uh, the time we check the middle. Okay, we will do what? We will store mid into answer. Okay, and once this is stored, we will do I equals to mid -1. Now you will be saying why sorry, mid -1 and minus and equals to mid -1, because have we are searching for the first occurrence. So first occurrence in a sorted array always be on the left side, right? So if we will do um, mid -1, so mid is this, and it is go -1, so that's mean now array will be like in this position. Okay, we will be searching for our element in this area. That's why this is necessary, and this is the only change in this um, change in this program. If we run it away, so I haven't used break. I think to print it, then we will once it's done, we will just simply assert our answer. Alright. Now if you can see, we have to know the first occurrence, right? So first occurrence will get index 4. So what is the index 4? 0, 1, 2, 3, and 4. So this is the same code. Okay. So this one was for first occurrence. Okay. So now we will do it same for a last occurrence. Okay. Let's do it for a last occurrence. So there is only one difference. There is only one difference in this whole condition. Instead of doing after saving mid into answer and equals to mid -1. So as we know, now our last occurrence will always be on this part of an array, right? So we will do what? We will going to do start equals to mid +1. So it will put everything there, and else everything will be as it is. If you run the program, if you can see the output is 7, that means array index 7. So if you can count 1, 2, 3, 4, 5, 6, 7, sorry, 0, 1, 2, 3, 4, 5, 6, and 7. At index 7 is the last occurrence of the 6, right? So, okay, so on this we will be doing one problem on a lead code. I hope you understand the explanation. So we will be doing one lead code problem on this. Alright, let's go. Share on screen. So this is a very famous problem. The problem statement is like create and share on screen. Okay, so this is the problem. So the problem is find the first and the last position of element in a sorted array. So if you can see, array is sorted. So if array is sorted, what we can do, right? We can use our binary search. First, first occurrence and the last occurrence, right? Or first position or last position. If you can see the examples, right? Example 57788 10 and 8. So what is the first occurrence of 8? It is on index 3, right? 0, 1, 2, 3, and the last occurrence on 4. Same goes here and here. And they are saying you must write an algorithm with O of login. If you are going to do a linear approach or brute force, it will always going to take you more time than O of n, right? N square or something else. To what will be the most efficient way? It will be using binary search. So how can we use binary search? So to use a binary search, we will create our one. We will going to create our one function for us, which will initially return us the values we want. Okay. So then public int, we will name it as first and last. Okay. And what it will take integer type array, or call is nums, and one integer type target, and one boolean flag. I will tell you why we are using boolean flag in a minute. Okay. So basically, what was the approach we already did? We did in our previous session we did one int start equals to 0, right? Then we did int uh, int start equals to 0, right? And end will be a nums dot length minus 1. Alright. After that, what we needed? We needed one more integer to store our answer. So answer equals to minus 1, right? Why? We will do that. Our start is less than equal to, and we find our mid element, right? First we need to find out mid element. So the mid element will be mid equals to uh, start plus end minus start divided by 2. I already told you why we are writing it like this. In the previous one uh, binary search explanation video, right? So in this, what we are doing, we initially did it. Now we will find our middle element. If target instead of x, they have given us a target, right? Target equals to nums of mid. Okay, we found our element, so we'll basically do what? Save our mid into answer, and I equals to and equals to mid minus 1, right? And else we used to do uh, else if target is less than nums of mid. So just and equals to mid minus 1. Okay, else it will be start equals to mid 1. Alright, so this was the basic thing. So this function will always return the answer, right? So now you will be thinking, how can we like return the given output, right? So for this, we can do one thing. You see the here, right? I created one flag. I will do what? Mm, what is this? Mm, we will like update our this section. Okay. If suppose our flag is true, okay, so our answer will be made right, and the high will be or end equals to mid minus 1. Okay, else what we will do, we'll put answer as it is. Sorry, we'll save. Okay, and we will use start equals to mid plus 1. So this will basically do what? First time when we will call, we in our question have to return an array where there will be first occurrence on index 0, there will be first occurrence, on index 1 there will be last occurrence. Okay, so to achieve that we need to create one array itself, right? Int array equals to new thing. The size will be 2 because why? Only two things need to be returned, right? So in this, what will we do? In, uh, in array of 0, index 0, we will call our function first and last. What we pass in nums, and what is the target, and second thing is for boolean. Okay, flag. So first flag will be true, and in array of 1, we'll call it again first and last. Same things will be like past Okay, then there will be false, and we will simply return our array. And if you can see here, we will get answer first time when we are passing true this portion. If target if flag is true, then mid or -1, that means the half part of this. We will ignore this part and we will only search in this part, so it will get a first occurrence of a array. And when we passes false, then this condition will execute mid plus 1. So the last occurrence on this side will be taken as an input. And let's run this code and see if our output is right or not. As you can see, we got our answer, right? Let's also check for other conditions also. So 577, and there is one condition, okay, which we haven't used. If target is not found in return -1 -1. So we can also write one function here. Okay. How can we improve it? I You can improve it by yourself. Uh, I can tell you what we have to do. Since they are saying if target is not found. Okay. So if target is not found, so we have to only return -1. Alright. Mm, so suppose, okay, so if it is not found target, so we will basically our answer is already -1, right? If any target is not found, so what's inside the answer? -1. So it will already return -1, right? So as you can see, we executed this program successfully. Runtime 0 ms. That means it is the fastest code we have written using binary search.